Welcome to another recording. I'm trying here to do it slightly differently. Today I've written down everything that I'm going to say or show you and just take you through it so it's a bit quicker. Hopefully it'll be no more than 5 minutes. So first of all, we are revising quadratics. And quadratics mean anything with an x squared in it. Welcome to another recording. This is about revising quadratic equations. Quadratics will have a square term in it. In this case, I've always used x as my variable, so it's always about x squared, but it could of course be p squared or q squared, or different types of things. Okay, first of all, there are three types of quadratics you may see. The most common normally is where you've got x squared plus 3x plus 2. That's a three-term quadratic, I will call that. Sometimes you get one where you've just got two terms but an x in both. So that's two terms but x in both. And occasionally you get these where you've got a quadratic and then a number. Very often these are the form that something's called a difference of two squares. I've got a squared number here because of course x squared is a square, and I've also got a square here because 25 is a square number, and a difference is to take away. Okay, so what are you likely to be asked when you get one of these questions? One very common question is to plot or draw the graph. Now, to do that, you're going to need to enter a table of values, and I've shown you how you might do that over here. So, first of all, it's asking you here, plot y equals x squared plus 3x plus 2 for x between minus 2 and 4. So you'd set out a table with your x values, and then you'd write in your x squared, because that was the first term, was x squared, your 3x, and your 2, and your 2. I would then suggest you calculate each line as you go along. So minus 2 squared is 4, minus 1 squared is 1, 0 squared is 0, 1 squared, and so on. Then the next line, 3x. 2 times 3 is minus 6, minus 3, 0, 3, and you'll begin to see the pattern of 6, 9, and so on. And here it's just a number 2. It's not dependent on anything to do with x, it is always 2. So 2, 2, 2, 2, 2, 2, 2. Then go back to your equation, look at it, it's adding, so I put an add. That's an add there, I write an add there. Then I go through and write add in all of these and all of those, and then I work out what it's going to be. So 4 add negative 6 is negative 2, add 2 is 0. Notice how I've done the y column here, the end of it in a different colour, so I can quickly pick off what they would be. Minus 2, 0, minus 1, 0, 0, 2, 1, and 6. And I'll be able to plot my graph doing that. Okay, I actually did plot that graph for you, and the graph I got was this graph here. And as you can see there, I've got a nice smooth curve like so. Okay, I plotted some other ones as well, and any graph with x squared in it will always be of that form. You'll always have a nice smooth U-shaped graph. If it was a negative x squared, it would actually be flipped up the other way, but they seem to be very rare. Okay, let's go back to our questions. So it said here, plot or draw. Now, I've done the same. I've drawn this one here, and I've drawn this one here for you, so you can see what they are. Just a case of putting numbers in a table, plotting them, and drawing them. I think you're also quite likely to be asked to solve them. So here, we've got solve x squared plus 3x plus 2. The original question, the original formula we're looking at was there, and now we've been asked to solve it here. We've got to solve this one and solve that one. To solve them, they need to be equal to 0, because if they're equal to 0, you're able to factorise them. Now, factorising an equation is a really important skill, factorising a quadratic, so I've written some things down here for you to do that. First of all, if it's of this form, factorise x squared plus 3x plus 6. That's a three-termer. That's when you're going to have to put it into two brackets. So you've got something times together gives you 6, but added together gives you 5. Well, 2 and 3. So I would guess for that one that that's going to be brackets x plus 2, x plus 3. I'm then going to put that into my normal grid like this to check it comes out. X times x is x squared, 2 times 3 is 6, then 2 times x is 2x, 2 times 3 is 3x. I've coloured it in carefully. The x squared and the 6, but then the 2x and the 3x joined together to give you 5x, which is what I originally had. So I know that's now correct. You may get asked to factorise something like this. This was the second type of example, and it was x squared minus 36. Again, as I said before, you've got a square there and a square there and a takeaway, and a takeaway is a difference. So this is a difference of two squares. Difference of two squares, it's going to be x, the square root of that one, and the square root of that one of them plus, one of them minus. So the square root of x squared is x, 1 there, 1 there. The square root of 36 is 6, 1 there, and then one of them plus, one of them minus. I've also just times that out for you there so you can see that x plus 6 times x minus 6. We use the same colour coding as well. And of course, the plus 6x here cancels with the minus 6 here. I've just shown you another simple, not so simple example of a difference of two squares. Sometimes they will make it look much more complicated by putting a coefficient or, if you like, a number in front of the x squared. But if you notice, 4 is a square number as well. So 4x squared is a square. The square root of 4x squared is 2x. The square root of 100 is 10. It's a difference. Square root of 4x, 2x, 1 in each bracket. Square root of 100 is 10, 1 there and 1 there. So it's x, 2x minus 10, 2x plus 10. I've also again drawn it in the usual grid formula so you can follow that through. You can stop the video and have a look and see if you're not too sure. And the final thing I've got to show you with this difference of two squares method, I've seen this on the paper recently and thought it was really quite nasty, and I don't want you to fall for it. This example here, I've got 12x squared minus 300. Now neither of those are square numbers, so it looks really tricky. However, if you think about it, you can factorise a 3 from both of those. Take the 3 outside the bracket and you're left with 4x squared minus 100. Now that's the question we've just done up here. 4x squared minus 100. So you know that that's 3, big brackets, 2x plus 10, 2x minus 10. Which in the end will become 3 brackets, 2x plus 10, 2x minus 10. So you've gone from what is an almost impossible question by a little bit of factorising and noticing you've got a factor of 3 in both. You can do that. Just look at this number. This is normally the key, together with this one. Can you get that down? Is there some easy multiple that is of a square number? Be careful with 25s. Quite often they're like 75, because 75 is 3 25s, and you'll find that's 3 times another square number there. Okay, the other type of factorising, it's the third one we've got, and this I call the basic like linear, or the two-term x in both. You look at this, people see the x squared and immediately they jump to trying to put it into brackets and get in a terrible confusion. It's very simple. The highest common factor of both in this case is 3x. I can take 3x out of that term and 3x out of that term. There's my 3x outside the bracket. What do I times 3x by to give me 6x squared? 2x. What do I times 3x by to give me 3x? 1. So then I've factorised it there. Okay, that's the factorising bit done. Now, over here, where we originally had, I'll just take it back so you can see where we are. That was our introduction sheet. Then we said plot and draw them. I've explained that. Now we're solving each of these. So, solving the x squared, solving the x squared plus 3x plus 2, the 3-termer, that goes into its 2 brackets. Those 2 brackets have got to equal 0. Now, this bracket, if that came to 0, timesing whatever this one is, anything, the whole thing would be 0. And similarly, if this bracket here was 0, whatever this bracket came to be, it would be 0 as well. So if I pick the number minus 1, x plus minus 1 will become minus 1 plus 1, which is indeed 0. So I've got 0 here. This bracket would actually be 1, but 0 times 1 is 0, because it's 0. It didn't matter what this was. And similarly, if x equals minus 2 plus 1 is minus 1, but minus 2 plus 2 is 0, and 0 times whatever we had here, it was minus 1, but it will of course be 0. So I know that all of this will equal 0 if that bit there can equal 0, i.e. x is minus 2, or this bit here equals 0, x is minus 1. So I've now solved that equation. X can be -1 or it can be -2. It's got two answers there. Don't forget when we plotted our graph, it was up here. If we look closely at this graph, we've got two solutions there. That's -2, and the graph there is 0. The y value here is 0, so the x value that gives that y value of 0, the coordinate here is -2, 0. It's a slightly strange scale here, but obviously that point there is halfway between 0 and 1, so that's -1. So -1 is 0 as well there. Okay, so that shows you why you get your two solutions. Going back to this particular, it's gone very quickly there, sorry. Going back to this one, x squared minus 25 equals 0. That is a difference of two squares. Difference of two squares, x plus 5 minus 5. How do I make that bracket equal to 0? X has got to be -5. This one equal to 0, x has got to be 5. Okay, I'm worried time's ticking on. This one, x squared plus 4x equals 0. Factorise that, it's x in both terms 1. It's just an x is the only highest common factor, so it's x times x gives me x squared, x times 4 gives me 4x. Well, getting that bracket to 0, you'll practice at that now, that's going to be x equals -4. This one, how do you make that x equal to 0? Lots of people struggle with this. It is just 0. X is 0. There we go. So x can equal 0 and x can equal -4. Okay, right. That's the basic factorising done. I just want to look quickly, scan out there so I can see where I am. That's where I am. Sorry, I hope that's not making you too dizzy. We've done those. It's this bit I want to look at. You may be asked to solve an equation which you can't factorise. Now I've made a mistake here because I think this one you can do, because that could be x plus 1 would factorise. But in the exam, they will say to you, for x to 2 decimal places. This is really a very bad example because it wouldn't work. What I might actually do for you now is just quickly change that so that you can get a question that you might actually get asked. Right, that won't rub out for some reason, so let's just change that to 3. Okay. So, let me just check that isn't going to be too easy. No, that's fine. So for x, use, and it says to 2 decimal places, you must use your formula. The formula for this is for ax squared plus bx equals 0, x can equal -b plus or minus the square root of b squared minus 4ac all over 2a. So in our equation, a is equal to 1 because the number in front of the x is 1, b is equal to 2, and now I need to go back and change that c is now become 3. Okay. So putting those numbers into my formula, so it's -b, so -2, plus or minus the square root of b squared, b is 2, 2 squared, minus 4, a is 1, c is 3, ac, I need to change that to a 3. It wasn't so bad actually getting it wrong because it's making it clearer for you now. That's a 3, not a 1 by the way. And then all divided by 2a, so 2 times a is 1. Okay, you put that in your calculator. You don't have a plus and minus button on a calculator, so just choose the plus the first time round. When you've entered all that in, don't press delete, just press replay back through the equation and change that plus to a minus. Okay. Another thing you may be asked when it comes to quadratics is they may give you a question where they've drawn the graph and ask you to solve the equation. Okay, first of all, I've changed my mind out. I went too long explaining that one, so we're not going to do that question there today. Right, we're just going to do this top one. It said, the graph of y equals x squared plus 3x plus 2 is drawn. Solve x squared plus 3x plus 2 equals 10. It's a really straightforward question. I do hope you'll get this right in your exam because it is so straightforward. You know the y value here, so I'll jump up there. The y value here has been changed for a 10. So you know the y coordinate is 10. Y equals 10. So all you have to do is on the graph they've given you, draw the line y equals 10, which I've drawn across there. Okay, I drew the graph on the iPad for you, so you had a copy of it. I'll just scroll out a little bit now so we can see it all in one go. There we go. Okay, so there's the graph. that was the graph y equaled, I can't remember what the graph was now, let me just scroll down, y equals x squared plus 3x plus 2. I've drawn that for you on the computer. And now I've drawn that y equals 10. So that's the line y equals 10. Where does it cross? Draw a nice straight line with a ruler. Don't have a ruler function on this, unfortunately, down there, but I reckon that's minus x equals 1.7. And don't forget it's quadratic, so there's two solutions. There's one there, y equals x minus 4. I'm just going to zoom in on that a little bit, so that if you want to, you can have a look at that and stop the video to check you know what you're doing. Okay, we're getting very near to everything I recorded. I've got one thing down here, this simplify here. This is something else that may come up. Simplify that expression there. You need to spot that you can put factors into that. I didn't do this for you so I could show you as I went along. So first of all, the top is going to become 2 brackets. That's a 3-termer. The bottom is also going to become 2 brackets. That's a difference of 2 squares. Now the difference of 2 squares is quite easy to do. It's going to be x and x. The square root of 9 is 3, so 3 and 3, one of them plus, one of them minus. I've now got to try and factorise the top. Now, I know it's going to want to simplify, so I'm guessing one of these is going to be, one of these brackets here is going to be on the top as well. So I think that 15 is going to need a 3 in it, so that's going to be a 5. So I'm going to go with 3 and 5, and 3 add 5 does give me 8. So I know I need a 3 and a 5. And if I add those together, I'll get an 8. So that is the same version written there. The same thing in factorised form. Now when I look at that, I've got a repeated factor. That one there is the same as that one there. So I can just cancel those out. That one can cross out with that one. And I'll be left with x plus 5 divided by x minus 3. Okay. That's simplified now. Doesn't matter if you leave those brackets in, that's absolutely fine. There you go, simplified version. Right, let's just take us back to the start. We were there. Okay, I did do one more thing, which is some tricks the examiners sometimes throw in on the quadratics just to confuse you. So that was supposed to say tricks and uses. So first of all, solve this equation. Let's just get that a wee bit bigger for you. Solve this equation. Solve x squared plus 3x equals 4. You've got to think, you can only solve a quadratic if it equals to 0. So can you change this equation to be equal to 0? You can only solve the quadratic if it equals 0. So x squared plus 3x equals 4. If I take 4 from both sides, that will become x squared plus 3x minus 4 equals 0. Now the minute it equals 0, I can solve it either by factorising or by using a formula. This one I can factorise, x plus 4, x minus 1 equals 0. So x equals negative 4, make that bracket there equal to 4, means x equals negative 4, or x equals plus 1. That will solve the equation. That's quite a common trick. They won't actually do that very first stage of making it equal to 0 for you. They'd mess about with it so it isn't. Sometimes they might have had x minus 4 equals minus 3x, and you'd have to add the 3x to both sides to get yourself sorted out. Don't panic, just try and do a basic manipulation to get it equal to 0. Be confident, have a go at it, mess about a bit, I'm sure you'll get there. Another thing, they like wrapping it up in words or a problem. So, a rectangle is 3 centimetres longer than its width. Sorry about the bad writing. It has an area of 4 centimetres squared. What's its length? Rectangle. Draw it. Its length is 3 centimetres longer than its width. So that was x, that would be x plus 3. The area to get that is going to be x times x plus 3. And you know it's got to be 4. Multiply it out. X squared plus 3x equals 4. You can't solve that as it is. You've got to change it to be in the form equals 0. And as you'll notice, that's the question we've just done up there. So x can be equal to minus 4 or x can equal 1. Careful when you answer the question. They asked you, what is its length? You know you've got two solutions here. One of them we say is trivial. X can't be minus 4, but x could be 1. So if x is 1, that's the width, be careful. What is its length? The length will be x plus 3, 1 plus 3, which is 4. Okay, one last thing. If it says the length is 3 times the width, that's x and 3x, which will give you 3x squared equals a. I was hoping to keep it to under 10 minutes. I've made it in 20. Hope that's been useful to you. Do let me know if it's not. But even better, do let me know if it is. So that's quadratics. And quadratics means generally equations with squares in them. Do check the other videos. Thank you very much.